Very good evening, students. Welcome to Cybervidyapeeth Foundation. And today we are going to see a project where we will analyze DOS attack data. Okay. So today's session is very important. So just join fast. Don't go anywhere. I am starting our session within 5 minutes. Okay. Yes, good evening, students. Okay. So students, just join first. Tell your friends to join first. That's why we can done our project. Okay, so our time is already over. So let's start with this. Yes, good evening. So let's start with this 25 students. So here we have exactly two data set. Okay, you can see here that one is train and one is for test. Okay, so simply at first we will load the data set. Okay, but one more thing, whatever the module or the library we are using in our project, so at first we will declare all our libraries and their modules and functions. So we need at first that we need 3D access, okay, for some purpose. So that's why we will use MPL toolkits dot mplots 3D, whatever we discuss it with it in previous class. After that, access 3D, yes. After that, we will use pre-processing, okay. So inside this pre-processing, that here is a class, or you can say a function, that is standard scalar. But at first we'll import this pre-processing, okay. So simply from scalar we are importing pre-processing. After that, from scalar naive bias, okay, scalar naive bias, yes, we just import Gaussian naive bias for classification. So it was a homework I already gave you homework yesterday. So I think all of you done it. And yesterday I already shared all of our notebook, whatever we done here. So yes, Gaussian naive bias. After that, so we need also one more classifier, that is decision tree classifier. Okay. So also it's come from scikit-learn, and from the tree, and just import the decision, yes, decision tree classifier. And also we need, oops, yes, we need the matrix. Okay, so today's session is very important, please. I can see only 31 students. Why? Because the video is available in YouTube anytime. Okay, let's continue. So we need also matrix, okay. And after that, we need matplot library for plotting our data. No, it's pyplot, yes, as PLT. Okay. And for linear algebra, we need numpy, yes, numpy s, np, yes. Also, we need to import OS, that means our operating system, for the path of our file location. And also all of you know the pandas. Okay. So I think that's okay. But one more thing I want to add, if it could be needed, so it's better that I'm importing the standard scalar. Okay. Oops. Oh, here is my fault. That is from, yes, now it's done. So this library, we are using this library. Yes, good evening. Using this library for our DOS attack data analysis. Okay. So just I want to see my paths of file, and for this simply we can write a loop. Okay, like this. After that, file names in os.work, and inside it just pass my file folder path. Okay, so that is inside my users. Oops, what's happened here? Just a second. So yes, like this. So no, okay, just a second. I'm copying the path. Yes. Now users. Yes. Yes, now it's working. Yes, desktop. Inside my desktop, data science, and inside there is a folder that is DOS attack dataset. Okay. Now it's cool. So after that, just a second. Yes. Now it's working. Now I'm simply another loop. Inside this loop, file name, in file names, whatever here. Okay. Yes, file's name. So it is a nested loop, and I want to print all my directory name and file name. Okay. So this is simple, that waste.path. Okay. So this comes under operating system, because here we already input the operating system library. Okay. And I want to join my directory name and also all file name. Okay, so if I print this, yes, here is some mistake in spelling. Yes, you can see here all my, so this is our current where we are doing this. Okay, Untitled. This is a new notebook for all of yours. Okay, and this is my train, this is my text data set, and you can see the paths. So okay, I think it's better. So yes, good evening. After that, we will load our train data set. Okay, train data set as df1. Okay, that means data frame 1. So simply just pd read csv. After that, give this train csv, yes, like this. And if I want to see its head, okay, so it will take some time because it's a big data set. Okay, it is a big data set. So for big data set, yes, so this is a MacBook, so that's why it can handle. But if you do with your Windows operating system, it might be crash. So let's see the shape of this. You can see here 8,09,361 rows, isn't it? Okay, so 8 lakh rows here and 78 columns. Okay, 78 columns, and we don't know what is inside this column. Okay, so but here is a good thing that you can see here. That means yes, there is some column name that is less than the length of 10. Okay, so we can identify all the columns like this, that if you, so for this we will go for some text. After that, we will make a function for histogram data analysis. Okay, so that is nothing, just look here. Okay, so I'm writing here that histogram data analysis okay, histogram data analysis with deeply. Yes, so for this is a big data set. You can see here that 8 lakh rows and 78 columns. Okay, so how can we plot all the data in histogram? So that's why we have to reduce. Okay, we have to reduce some column. That's why we are making, just look here at the function, and the function name is supposed like that, plot per column distribution. Okay. For I'm using camel mountain column. Okay. Distribution. Okay. Now inside this, I am passing three parameters. What is this three parameter? Okay. So one of is my caption. That means we need, okay, we need 10 subplots that we can visualize the graph. And one is that graph per row. Okay. That means inside the plot per row, what is the number of subplots? Okay. And what is the total number of subplots? So I'm writing here n means number of graph shown. Okay. That means number of graph inside a plot. And you can say number of subplot inside a graph. Okay. So I'm writing here n graph shown. Yes. And one parameter is one graph per row. So this is pretty critical. So just have a focus here. Okay. And keep patience. So at first, we will count all the non-unique values. So non-unique values means it will, okay. So that means here you can say this is 1 and 1. So this is our duplicate values. So non-unique means we have just remove all the unique values, and whatever the non-unique values, just store it inside a variable. So that is, I'm naming the variable that is non-unique. Okay. So n unique. Okay. Yes, like this. After that, according to this parameters, so this is our original data frame. Okay. Whatever is there, forget it, because we will call this function with its parameter value. Okay. So according to this data frame, if I give here, suppose like this, I'm showing you. That means if I call, suppose plot per column distribution, and inside it, if I pass my data frame 1 and pass the subplot number and pass the number of row, okay. So here you can see this df will define this df. That means whatever we named here the data frame. Okay. So this is our actual value. Okay. So just according to this data frame, this function parameter, we will make some change. And after we pass the value, then according to this function, all the data will change. So now I want to call the n unique function. Okay. So it will remove all the unique values. Remember, all the unique values. Okay. So it's okay, done. Now we will make some change inside our data frame, that here we will use a what is it? Yes, you can say just a second, that is loop that is loop comprehensions like this. I forget the name. So just look that we can run a loop inside a square bracket. So that's called exactly list comprehensions like this. Okay, so forget it. So column, for column in whatever in our data frame, and here is a condition that if n unique, that means this. Okay, so if yes, my n unique column is greater than 1 and n unique column is less than 50, then save it inside this data frame. So I am just showing you what it will do. Okay, so after that we have to, yes, if I look like this, yes, and if I here give our main data frame, just look here, yes, I think it's okay. And also, yes, so now you will see, yes, so if I do it, yes, so you can see our column is reduced. Okay, and if we want to that df1 shape, just see here, our column is only 12. Okay, that means what is its mean, and what is about here, you can see all the unique value is come. Okay, and whatever is the all the non-unique value, okay, is showing here, and whatever is the unique value, all are dropped by this one function. Okay, and also we remove our unused column, whatever we don't need. Okay, and now you can see the label here. So our label exactly represent, here you can see DOS Hulk, okay, Benigen. So what is those are? So you can read very clearly here, it's a prank virus. Okay, and prank virus, it will declaring a message that peace on earth, and you're inside your computer, you can say it's a birthday, it could be a birthday message, and inside your computer, poop poop, just like this, and it will appear inside your computer. Okay, and also all of you know that this is a kind of DOS attack. So that means all of you know what is DOS. Okay, and so you can see here our data is reduced with 78 column into 12 column. Okay, so that means tf1 dot shape, yes, 12 column. So I'm writing this. Okay, so that's why I have to reset the kernel, because I already initialize it. So I have to reset the kernel and again continue. Yes, just a second. Again, we will continue our function. What is this? Oh my God, it's not working. That means what? My system was hacked or not? Why it's not working? Oh my God. Okay, just a second. Yes, now it's okay, I think. Okay, let's run all the cell again. So I just want to show you what exactly this two line is doing. Okay, this two line. When we pass this data frame 1, our train data set. Okay, so I'm continuing. So just I'm unmarking, yes. And now continue. So for the shape, I want to use unpacking, because you see that our shape was 8 lakh into 12. Okay, so I want to give a name that my n row is 8 lakh and my column is 12, because after this two line our shape is 8 lakh into 12. Okay, remember, because I already show you. Okay, so now after that we have to we just list all the columns name, whatever we have, that means 12 columns name. So just column name, yes, the list function, and inside it pass the data frame. Okay, after that we need the calculate the n graph per row. Okay, this one. Okay, so this is n graph, that means number of graph per row. That means if, just a second, what is exactly this? I'm showing you with our drawing. That's why you can understand better. Okay. So this is nothing. So yes, so if this is my full subplot, okay, now this is my full plot. So I am plotting, suppose 5 plot here, 1 2 3 4, okay, here is 4. So this is the number of graph per row. Okay, so I think it's clear. So yes, where it is, yes. And now we have to calculate the number of graph row. Okay, so number of graph row, this is nothing but just my n column plus number of graph per row minus 1 and divided by this double divided, that means there should not come any float values. Okay, so n graph per row. So this is our number of graph row. Okay, and after that we just initialize a figure, and inside it we pass its parameter. That number is at first none. After that, figure size, our figure size should be, so suppose 6 multiply whatever is my graph per row. That means if per row the number of graph is 5, so that means it's 30. Okay, so according to our parameter, just pass it, and after that a comma. So that is the, I think is 30 is into 8 into graph per row. That means if it is 5, then 40. Okay, so figure size exactly 30 into 40 if you calculate. Okay, so I have done this because I have to plot two data sets. One is my train and one is my test. So that's why I just simply make a function, and that's why I can easily pass the second data frame with a one-line code. Okay, so just have a look. So after that, the TPI is equal 80 and face color. Okay, face color is equal, you can keep here white. Okay, and what is your is color? No, ed, yes, no, it's not coming. So I think I have some mistake here. Yes, double comma. Okay, so now check it up. Yes, now it's done. Our edge color is K, and we need a loop for plotting all the subplots. Okay, so why this loop? I am coming. Why this mean that whatever is number of graph row or number of graph per row, so that is our exactly this is our range. So we can give here, if we want to plot 10 subplots inside a plot or inside a figure. Okay, so inside a figure, if we want to plot 10 number of subplot, so just if you can give here 10, but I have to plotting this histogram for 2 data set, so I don't know what it will come. Okay, so that's why I just simply write here whatever is the mean of number of graph row or number of graph per row. So mean will return the minimum of both values. Okay, and after that it will fix for the range function. Okay, so I'm giving here the column and the n graph per row. So after that, yes, I'm moving in the function and I want to plot the subplot inside it. At first, the number of rows, after that number of columns. So I simply pass whatever is our number of rows, that is our number of graph row. Yes, and after that number of graph per row. Yes, like this. And what is the total? Because I is start with 0, that's why I plus 1. That means the first plot will be 1. Okay, the first plot number will be 1. And now I'm selecting the column data frame. So column data frame, and I am using the ilog, whatever we learned previously. So only the column I'm selecting and all the rows. Okay, so after that, so we have to give the name. No, we have to give the point is this and calling with histogram. Okay, so yes, so all the values whatever inside this data frame. Okay, and plot it inside this histogram. So I'm giving the points. Okay, after that we'll give the yes level. So y level is counts, and after that AICTE. What is it? What is the level you are writing? So just 90-degree. Okay, it will rotate at 90-degree. I'm showing you, because if it is a lengthy string, then it will override. Okay, so that's why we are using AICTE that will rotate. Yes, rotation with 90-degree. Okay, it's done. After that, just give the plot title, every single plot title. So now you can see now why this column name I am listing. So inside it, just create a F string, and inside this F string, I think all of you know this is simple Python. Okay, what is a F string method? And inside it, whatever inside this list, look at here, whatever inside this list, that the first plot, and give him the first column name. The second plot, I will be then 2, and give it the second column name. Okay, so after that, just simply I'm giving the column. Yes, the column. So oops, just a second. Yes, now it's okay, because it's under the string section, and there is also, I want to pass the I value. So I think all of you know about the F string. Okay, sir, wish you had shared those two CSV file. Okay, it's getting confusing now. Okay, don't worry. Just this function is creating for the APIs. Okay, so just you can also you can create the X train and Y train. So don't need to plot any histogram, and you can classify it. You can classify it with this decision tree classifier and Gaussian neighbors, but also we have to visualize some histogram plotting, correlation metrics for better understanding. Okay, so that's why this type of, and I am tightening all the layout. So that is tight layout. So what is the functions definition? That this function in PyPlot module of Matplot library is used to automatically adjust the subplot parameters. Okay, subplot parameters to give a specified padding. Okay, so yes, tight layout, just give a specified padding, that my pad is equal 1.0 and width height. Okay, like this, width pad is 1.0. Okay, after that height, yes, height pad is 1.0, like this. So there will be a space. So if I plot dot show, whatever you not understanding, just wait more 2 minutes. Okay, not shared, bro. What I not share, what I not shared. Okay, just wait 2 more seconds. That's why I can show you why this function. So now I think it's done. And if I run this again, and it's run. And if I run this function with my trained data set that is here, so if I run this, so yes, we have some issues. That means inside this function name, okay, so don't need to worry. And if I have some error, also I will no, there is no error, but here is some problem, that only here comes the 10, the 5 histogram. That means why the 5 histogram? Because for this range function, I give here that minimum of number of column, that is 12, and number of graph per row, that is 5, I think, because I pass here 5. Okay, so I think I have some mistake. So if I pass here, simply number of graph row, copy, let's see again what is happening. No, this time only 3. So that's why I can remove it, and I am simply give it here range 10. So nothing to audit. And if I do like this, yes, you can see 10 histogram. So I think you can understand a little bit. Okay, file I will share with you. Okay, don't worry about file. Okay, so all this all that previous file, that working with something NBA or something employees, I already shared. So today's file will also I will share in our group. So don't worry about this. So now you can see here, if I zoom in, that this is my forward push flex, backward push flex, and their histogram. Okay. So after that, this is for our data frame 1. And now we will go for another thing, that is our correlation matrix. Oops, wait. Yes. Correlation matrix. Yes, like this data analysis. So what is exactly those type of things? So if you sometime I want to show you, I want to tell you that I think all of you see the stocks graph. Okay, so stock graphs, and all of you see like that if you using some firewall API, there you will see some types of histogram or some types of graph that will represent that what is a malware, what is not a malware, where is the DOS attack. So like this. Okay, so we can visualize data by this type of graphs. And also now we are coming for correlation matrix. So just another function that is correlation matrix, and inside it only one will pass the data frame and the graph weight. Okay, and the graph weight, and inside it again nothing to worry, just we'll drop all the null function at first. So all of we know how can we drop the null function, that is drop na. After that we will reduce the column size, okay, for with list comprehension, and yes, like this column for column in data frame. And here is a condition that if data frame column is not unique, like this, not unique, wait, why my tab is not working? Yes, unique, I'm writing here, if my data frame columns value is non-unique and greater than 1, then store it inside this variable, and rest data just drop. Okay, now I want to see something, want to show you something, just a second. I'm creating here okay, creating here a box, and simply pandas is already there. So simply if you see like this, that if data frame inside first key is array 1, and inside it, wait, inside it, if the value is 30, 70 and 100, and also all our array 2 value is 65.1, comma 49.50, comma 30.7, like this. So this is our data frame, and I want to, yes, pd dot data frame, and inside it I pass my df, and if I want to print data dot this function that is CORR, okay, so if I pass this, so you will see something like this. Okay. So what is its mean exactly? So it is nothing that this function exactly find the correlation. Okay. Find the correlation among the columns in the data frame and using the Pearson method. Okay. So don't need to go deep, just remember it. So, oops, okay. Okay, that does not affect in our there. So just remember this core function. Okay. So it just find the correlation among the columns. Okay. So that just done it here with a variable that is core is equal data frame dot core, and all the data is already changed in like this. So now if I show it individually, you can see 68 into 68 columns, and row is also 68. Okay, because 8 lakh rows already reduced. Okay, so just okay, I am sharing. Just a second, I am sharing. Just give me 5 minutes. I am sharing the file. Just I am stopping my screen for 1 minute and I am sharing. Okay. Yes. Okay, students, welcome back. Just already I send it to one of our bots. Okay. So you will send it. It's a big file that is something like 324 MB and one is 150 something. Okay. So our so where we are now exactly already we done to make our data set with correlation. Okay, and what we exactly use here, use the Pearson method. Okay, so don't worry about it. So it's making the correlation among the columns. That means already the 8 lakh row is reduced within 66, 68 into 68 column. So I just want to show you it again. That's why you can understand betterly. Okay. So file is available online. No, already I think shared. So now after that we will create a figure, but before that I want to show you one more thing. That means, yes, like this, and here is our data set. So if we done something like this, that hey, data frame, please drop all the null, and after that here is a list comprehension, and after that if we make this, that means this will reduce the column. Okay, and after that if I call this function, and now if I want to view the shape, so look at here. Yes, df1, df1, this is our original data frame. Okay, yes, df1, so like this. So just a second and you will see some magic here. It's a big data set, that's why. So just wait for a second. Yes, you can see here 68 into 68 size. The row is 68 and also the column is 68. The correlation with the column. So that is the power of this function. Okay. So that means here you can see 8 lakh data. But for the correlation matrix data plotting, we have to reduce it, and okay, for our plotting purpose. So I'm just removing it, and already my data is changed. So that's why I have to reset the kernel again, and we will start move on. Okay, so I have to reset and run all the cell again. Oops, it's make it a problem. I have to close it again here. I have to close it and delete this cell. After that, I have to reset and run all the cells. Please. Yes, it's doing. Just a second. This star means it's working. Okay, it's running. Yes. So okay, now it's, I think, okay, that where we are after this, that means this 3 line will change our data frame with 68 into 68. Now we'll create a figure. Okay, So yes, num is equal none. Again the same, and figure size. Yes, I want to fix the figure size, but where is my tab is not working. Just a second. Yes, my oops. Sometimes, okay, my figure size. Sometimes I forget simple spelling. And here is the figure size is our graph width. Okay, whatever our graph width. So just give a parameter here and graph width into graph width. Because why is like this? Because this is a correlation matrix and it will show something like a square. And all of you know the square, that means n into n. Height is also n and wide is also n. Okay. So that's why after that, just wait, I'm passing the DPI is 80 and yes, phase color is my suppose W. And you can give anything, blue, red, green, orange, anything. Yes, my edge color is K. Yes, now my figure size is complete. After that, I will plot it by the function of mat show. Now you have a question that what is this mat show? Mat show function. Okay. So exactly, mat show function is used to represent an array. Okay, represent an array as a matrix. And in a new figure window. Just remember, it used to represent an array as a matrix in a new figure window. Okay, just this. Don't critical it. Okay, so I'm doing this correlation or okay correlation values inside this plot. Okay, so plot, yes, mat show, inside it passed all the values and my figure number is 1. Okay, because there is only one plot. Okay, so figure number is 1. Now here is interesting thing that previously we see here that the rotation is 90 degree. So my rotation is 90 degree. That means what? I'm zooming and you can hear, oops. Just wait, I'm showing you that if you look at here, you can see the scan, the value is in the 90 degree. Are you able to see? So I'm showing you, just wait. I'm showing you, just give some time to complete this function, that plot dot x takes, yes, and inside it just give the range of all the length of correlation column, okay, dot column, and after that just give here the correlation columns and all the name should be rotate with 90 degree. Okay, so the rotation is my 90 degree, and after that, because is AICTE, because suppose think about here, no, this is our previous class. Okay, just a second, where we are, no, okay, let me done it. Y sticks and here is the range length of column. So that means my data set, my current data set name is CORR. Okay, that shape was 68 into 68. Okay, and columns, so oops, it's a mistakes. So that is the range. So what does mean the range? Range means if we give range is 10, that means I'm coming after our output every line. Okay, for every line, just give me 2 minutes more. And there is no rotation because Y level is already all the Y levels is already printed horizontally. Okay, so PLT and dot, yes, here is another function that we are using, that is ZCA. So what is exactly the ZCA? So all of you know that it's a function in PyPlot module of Matplot library, and is used to get the current access. Okay, get the current access instance on the current figure. Okay, so I'm coming here. Just don't worry about those type of function. So yes, x-axis, and after that just pass this variable, whatever we plotting our points, whatever the points plotting in match inside this variable. Okay, and now after that we need a color bar. Okay, color bar, yes, we need a color bar according to our correlation matrix. Okay, so yes, it's okay. And after that we need a title. So all of you know that the title, yes, here is the title within a F string. That means that correlation matrix for DOS dataset. Yes, we can write this correlation matrix for DOS dataset. Okay, and if we done this, we can give also the font size is suppose 30. Okay, I'm giving the font size is 30, and plt.show, if we run this, so I think yes, one error. Where is this error? Yes, inside the color bar, but I give here a parameter. Yes, that's exactly wrong because I have to call the tick bottom. Okay, tick bottom function. Yes. Now if we pass this, yes, is done. Now if we call this function for my data frame, this data frame, all of you can see for this data frame, and whatever is my graph width, I want to give it something like that, suppose 20. Okay, so if I call it, so let's wait because it's a big data set. My computer needs some time. Just nothing. Okay, we have some error. That means yes, a rotation. Oh shit, that is exactly the rotation. Okay, okay, so let's see where is the, up to this I think all is clear. Now yes, it's done. So this is our x-axis, all of you can see. So if I not give here the rotation 90°, so this level, okay, so this I am showing you what is happening. So if I not give it here, and after that if we run it, so yes, just wait for 30 seconds or 20 seconds. My computer is very fast. Okay, yes, so you can see all the string is overriding. Okay, so that's why we use this function. And what is this exactly? The range. So I'm coming at first, just yes, rotation. At first I just do it. Yes, wait 20 seconds. Yes, so now I think it's okay. So if I print it 90° horizontally, so now you can see this type of, and what is this, why this range? Because I need 68 boxes from row wise and 68 boxes from column wise, and that's why for the length of columns, that means all the columns length, and that is our range, and the column names. So I think this parameter is for the size of this string. Okay, so also all here you can see for the y level. So y level nothing to do, it's okay, it's already horizontally, you can see. Okay, and after that this is our color bar. You can see here, this is our color bar. Okay, and it's nothing, it will just okay, it just used to get the current axis instance on the current figure. Okay, matching the given keyword argument. Okay, and this is our title. You can see our title, a nice title here, because I increased the font size with 30. So I think up to this clear, but what is this matrix is saying us that if point, yes, if under the point 0, that means this box, okay, you can see the color. This is our corrupted values. Also this, okay. So only the one that is our pure value, okay, and diagonally you can see like the confusion matrix, okay, yesterday whatever we learned. So that is our exactly pure values, that means pure data, okay, and that is our corrupted data, okay. That means this one, and it's you can see the highest pure data is the is yellow. After that it's come like this purple, or you can, yes, I don't know what is the color. Okay, so I think up to this is clear. Now we will see some scatter plotting, and after that directly directly we will go for, okay, we will go for test and train. Okay, so don't go anywhere. Just I need a comment that uh, about 50% is clear. Not need to understand 100%. 50% is clear. I need a comment, please. Okay. No comments here. Less than 50%. Okay, don't worry. Because if you practice, okay, so then you can understand. So this is nothing, we just create a function, okay, create a function for our trained data set visualization in correlation matrix. So, and just simply call the function with its parameter value. Okay, just I call my data frame 1, that means this one, this data set, my train data set. Okay, so after that we'll go for firstly in scatter and density plus. After that we will directly go for our original, that means whatever we want to do with this data set. Okay, this is nothing, this is for only the plotting data, for visualizing. So yes, scatter and density plots. Okay, here is also we are creating, yes, plot scatter matrix. Oops. Scatter matrix, and inside it 3 parameter. One is plot size. Yes, one is plot size. One is text size. Yes, like this. Okay. And after that, at first, we only include the numeric columns. So inside it, all is the numeric columns, but you can see here, the label is the last label that is exactly showing us the attacking category. What is it? Attacking category. I mean to say, I don't understand. Okay, so I think already I discussed this type of function, that is drop, that is yes, shape, that is list. So already so if you, I think you just go for our previous lecture. So I think you can understand more. So where here, so just select D types. Oops. Yes, select D type. What is happening? Okay, don't worry. Select D types and include. What is include? NP dot number. So yes, that means only select the data type, okay, where the columns value is numeric. Just in simple line, only select the data type where the columns value is numeric. Okay, so that means this label, that is a objective value, this will drop. Okay, so after that we will drop all the null values with drop null function. After that, there is a list comprehension for reduce our, so column, for column in data frame, if there is a condition that data frame column is not unique, no, not unique, no, QUES, not unique and greater than 1. And after that, column name, like the previous inside the histogram, whatever we done, that is column name is equal our list of data frame. After that, here we will do a condition, a small condition, that if my length of column name, if my length of column name is greater than 10, okay, is greater than 10, so give us the column name up to 10. Okay, so you want to just you want to learn it very deeply, please, I need an answer. I will show you very deeply, every line by line, but our time is not enough, so you have to continue at least 8:30 or more than 8:30, so I can go for very deeply. I want answer. Just give a comment. Sure. Okay. So exactly what is happening here, I'm just uncommenting it. Just let, okay. Exactly what is happening here. Just give a minute. Okay. I am again load this data frame. Okay. Load this data frame with the name of data, another variable. So this is, I think, clear to all of you, because I just read the CSV file and I want to visit its head. Just give 30 seconds to load it, because 8 lakh rows. Okay, 8 lakh rows. All of you know that. So up to this is clear. Okay. So I'm removing it. I'm only showing that our data shape is 8 lakh. Okay. So up to come in. So I'm showing you, yes, 8 lakh and 78 column. So when we run this first line, what is changing? Okay. What is exactly changing? I'm showing you. That means, yes, you can see here. You can see here the label. Please answer me. You can see here the label, because already there is label. There is a string type column in simple. Yes. But so what is this line means? That here you can see that, yes, please, here data frame, please select the data type only the numeric values. Okay. Now if I write data dot shape, yes, you can see 77. That means here you can see 78. That means one column is dropped. Yes, up to this. Okay. Now I am going for second line. Okay. So I am going for second line. And here you can see why you will not understand. I'm just okay. Now up to this, it will drop all the null values. So let's check that our shape is changed or not. So I'm seeing that 8 lakh 77, 8 lakh. That means, what is that means? That means there is no null values. Okay. So up to this is clear. Okay. Up to this is clear. Now, while I go for the third line, what is the change? So I am exactly uncommenting it. Okay. No. Let it be like this. While I am going for the third line, look at here. Yes, going for the third line, and if I want to visualize the data, yes, here is some mistakes. Yes, okay. Okay, and also where is off? Just a second. I have to, yes, now I think it's okay. Yes. So what is its mean that 68 column, why 68 column here is coming? So that means here a condition, okay, condition, that means inside the data frame, hey data frame, inside the data frame, go for the column. Okay, I'm going for the column. Okay, I'm talking with my computer. Yes, I understand up to this. Now, if any column where if any column contains all the unique value, okay, just focus that if any column contains all the unique values and that is greater than 1, that means here you can see that 1 1, okay, and that is greater than 1, then just drop it and give me the rest columns. Okay, up to this is clear. And if I now want to see the shape, you can see my 77 columns is reduced with 68. Up to this is okay. I need a comment for the third line. Okay. So after that, what is telling us the fourth line and this condition? Okay. So I'm coming. Why you will not understand? Yes. So just look at her. At first, I am uncommenting it. Okay. And I want to see the column names. Okay. It will not print like this. Okay. Here is the data. Yes. So, yes. Now you can see all the 68 column name. Isn't it? Okay. So if here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17. So what is my length? This one, 70. So I just simply here give a condition that if the column name length, look at here, if the column name length is greater than 10, then give me the column name. Okay. So I'm just reducing here. I'm just printing here the column name. Okay. So you can see by the 68 column names, whatever is greater than 10, the length of the column is greater than 10, is contain 70. So like this, if you anything you read 1, 2, 3, 4, 5, 6, 7, 8. Okay, give me some why it is coming here. This is 0, 1, 2, 3, 4, 5, 6, 7. So yes, I have a mistake here, that column name is equal column name, and after that if I print column name also okay, so this is only 8 characters, but I give here the length is greater than 10. Okay, just a second. If why it is not working? Okay, I'm again going there where we are exactly. Yes. So what is it exactly is doing? I'm showing you that up to 10, and if I print the column name, yes, you can see only from 0 to 10, 10 column is here. Okay, so that means, okay, so now this 68 column is reduced with only 10. Okay, so if I dot size, no, size is not available, yes. So you can see here that here is the 10 column. Okay, so now if I done it inside this function, so now my data shape is 8 lakh into 10. Yes, I'm already using, but okay. So I think up to this is clear. I'm not still changing our data frame. Okay. Just I need the column name up to 10 and whose length is greater than 10. I think up to this is clear. Okay. So after that, I'm coming. Yes. So after that, if I give here, okay, if I give here that my data is equal data and all this column name, oops, yes, column name like this, and if I print data dot shape, so you can see I reduced my column 68 to 10. So I think up to this is clear. Okay. So after that, nothing, just we will create a figure and we will plot all the scatter matrix, and inside this scatter matrix, we will pass the values. Okay. So, and also one more thing. So don't, so I think all of you know that after that it will come that already I told you that if I call the data dot core function, yes, like this, and now if I want to visualize core dot hit, yes, now you can see, that this is the correlation. Okay, and you can also visualize, just a second, just yes, you can also visualize all my diagonal values is on, isn't it? Yes or not? No comment. Yes. Okay. So I think up to this is clear. Okay. So I exactly need this data frame, these points, okay, these points to make a scatter matrix. Okay. So this is nothing critical, just one by one line I am showing you. I already showed you. Okay, so let go inside our function. Okay. Okay. Also this. Oops, no, don't need it. Oh shit, I already ran it. Okay, just a second. It will take some time. Yes. Now I don't need it. Okay, so where we are, we are now, I want to change the data shape into 8 lakh into 10. So that's why I just easily call data into column name. After that, I'm making an axis and I'm plotting here. Okay. Plotting here I scatter matrix, nothing. Just it's very simple, and I'm pass the data. That means my DF. Now my DF shape is what? 8 lakh into 10. Remember, my DF shape is what? 8 lakh into 10. Why 8 lakh into 10? For plotting this scatter. Okay. So now I pass the data. After that, already, okay, our alpha value is here, the scatter matrix parameter. Okay. So alpha value is 0.75. And my figure size, yes, my figure size is plot size into plot size. So that means, yes, inside a square bracket, just plot size into plot size. My figure size, whatever we will pass the value, okay, that will come here because it's inside a function. And after that, my diagonal, yes, my diagonal is KD. And now I'm making my data frame, okay, correlation values, okay, correlation values. And after that, why this loop? So this, no, we don't need any loop. So that was critical, and you will I'm not this time using any loop. Okay. So plot dot subplot, subtitle. So simply plot dot subtitle, and inside this subtitle, I'm giving here scatter and density plot. Okay. Yes, like this. And now plot dot show if I want to. Yes, my function is complete, and now I want to pass here I want to pass the value of for my data frame 1, whatever is there. Okay, for my data frame on, and it will work according to the definition of this function. Okay, and I'm passing here the size is 20 and yes 10. So it will take some time. Don't worry, we'll wait just 30 seconds. My computer is very fast. Okay. Just 5 minutes after that, all is over. After that, we just make data for train and test. Okay, and we'll create a class category. Okay, just don't this is the critical section. After that, you will understand very simply. After that, it will take some time because it's working for 8 lakh rows. Okay, so 8 lakh rows, so that's why it will take some time. So just wait, I'm coming within 2 minutes. Okay, don't go. Okay, there is a error. Okay, let's see what is my error. That subtitle shit. I miss again the spelling. Okay, just wait. What is the yes subtitle? Okay, this is not the subtitle. That is subtitle. Yes. Now I think it will work. So okay, we will not wait. So now I showing you only the train. So after that, we also load our data frame 2, that is our exactly test set. Okay, so just simply pd dot read csv, and our csv file is exactly what is it, our test dot csv. Okay, so yes, test.csv. After that, if we want to visualize df2.hit, we'll see it after complete this cell. So just wait. Okay, here is some problem with both function. So I think I have to restart the kernel again. So just give me some time. Restart all and run all the cells. It's also not working. Oops. Yes. Now I will restate the kernel. Yes. So it will pretty pressurized for my computer because a lot of task is already running in backend. Okay. So wait 1 minute to all of its output. Okay. Yes. Just don't leave because our main part is already our main. Oops. Yes, it will take some more time because a scatter needs a lot of time. Because all of you know it's a big data set. Only if it is possible for short time, if it is a cloud machine. Okay. So that's some types of special machine you have to buy from Amazon, that means AWS, or you can buy from Microsoft also. This type of machine is cost for 1 year is something like that 45 lakhs, 65 lakhs. Oops, still it's running. Come on. Yes, all is right. Okay, okay. I think I don't need this text size, but overall, it should be give me a matrix. Oh, come on. It's taking a lot of time. Why? Mm. This text size is valueless because I don't use a for loop here. So, okay, I'm removing the text size, and again I am reset my kernel. Why it's not? Why it will taking so more time? Come on, do it first. My computer is warming. Yes, this is done now. Correlation matrix is running here. It's coming up to 8 cell. Yes, it's done. Now it's for this. And please. Come on. Okay, up to this, we'll go for we have to load the another, that is df2 is my read cs band inside it. The test oh it's taking more time, so please student wait. I have nothing to do. My computer is already warming because it's a big data set with 8 lakh row. Okay, and also I can skip it because time is already 8. And up to a lot of thing is oh, why it's taking so much time? Come on. Okay, I am showing you at the last because it's doing. Okay. It will take a lot of time. And we have a lot of reset and run also. Yes. At the end, we of course we will do it. Okay. Just our main part is I am yes, first run all this. Just we not able to visualize scatter and density plots. Don't worry. Yes, it's done. Read CSV, yes, I need to here keep the panda and df2. So what is my df2? My df2 is my test data set. Okay, that means data frame 2. Okay, yes, now it's coming here. So if you want to see the shape, just look at here. This is 3 lakh something, okay? And also the same level. So what is the category? I already discussed at the beginning that we have 3 category of attacking type. So one is two up is the DOS attack type, and one is prank virus, okay? And their data set is here. So now we just simply, I'm not calling these two function, I'm not calling these two function for data frame 2 because it will, okay, I'm showing you, yes, for data frame 2, and I'm also plotting a correlation matrix. Yes, it's done. Correlation matrix for data frame 2, and you can see here. So this is the correlation matrix for test set of data set. Okay. So now our main part is identify the classes. Okay. So identify the classes. That means data frame 1, inside this I give its label. What is its label? Label means this. Label means categories. Okay. So yes, labels, the column name is label, and if I give here that unique and data frame 2, inside it the label. So remember, this is data frame 1 is our train data frame, and data frame 2 is our test data frame. Whatever we are going to test, that according to our train. Okay. So unique, yes. So if we like this, you can see 3 types of data class. Okay. So I'm writing here that identify, okay, the classes. Okay. After that, we will label encoder object, that means knows how to understand word label. Okay. So that means whatever we discuss in our previous section, just a second, that means I'm showing you, yes, only 42 student is just a second. Yes. So in the previous class, we discussed that oops, yes, my computer is overloaded. Okay. So if okay, let me show it here. If there is a scenario for cat, dog, and pandas, so we will give for cat the class level is 0, for dog the class level is 1, and for panda class level is 2, because we need a, okay, we need a y value. Where is this value will indicates our categories. Okay, so we have to change this level. Okay, we have to change this level according to their categories into a class that will represent 0, 1, and 2. So for Benigen, we will give him a class of 0. And for DOS, solo iris, and we will give it for 1. And for the Hulk, we will give the class name is 2. So how can we do that? So it's very simple. Here in the top, you can see here a module that is pre-processing. Okay. So we just call this, I'm giving a variable here that is level encoder, and inside it pre-processing dot level encoder. I'm calling this function and just simply here passing the level and just call the variable that is level encoder, and I'm calling another function that is fit transform, that please transform it into a class. Okay, a value of class. So I'm passing inside this parameter for test train value level, and again I am going to do it for for also test value, like this. Okay, up to this is clear. Now we will see what is exactly our change. Okay, so if I here df1 dot hit, now you will able to see here the label is converting with numeric value with 1, 0, 0. Okay, and where is the Hulk? There will be 2. So I already view here only the head, that means 5 row. If you go for some more value, I think you can see, here is 2. So only I categorize the class with 0, 1, and 2. And also, if you want to view that this hit, also you will able to see, all of the categories here. Okay, the level category. So previously, our label is like this. Okay, our objective. But I convert it into a classes with this simple processing module. So I think it's clear to all of you. I'm clearing. So now, so it's done. Now we will simply just make simply our train and test set will. Okay, so at the X train, so I am just call the data frame 1, and I want to all the columns but without the label. Why without the label? Because it's our y value. Okay. So here our dot drop function I am using because I don't need the level. Okay. And I have to also give the access like this. Access is 1 because column wise you just drop the label and rest of the value store inside X string. After that, we need test, and that is comes from our data frame 2 because we know this is our test value. So yesterday what we done that we split train and test into 80 into 20%. But already here we have the train data set and already we have the test data set. That's why we don't have to split it. Okay. So remember. So just also all in the data frame 2, I don't need the label because label is for y value. Remember. Axis is 1. Okay, now it's done, but here is a mistake. Yes, like this. And my y train is only the level. Okay, so only the level, nothing else. And my y test is only my level of test dataset. So you will see if I print like this. Yes, print like this, that x string dot shape comma x test x test dot shape comma y train dot shape comma yes y test dot shape comma just a second. You can see here that our test is 8 lakh, then our the train is 8 lakh into 77, that means 77, but our main row is 78. That means I drop the level, and here you can see only the level function is here inside this white train because I indicate here, please, only I need the level. Okay, so now up to I think this is clear. Please, I need a comment. Now just simply we fit it inside our classifier. Okay. Yes. So, oops, sorry. Just here, first is for name bias. No, yes or no. I don't know why. So I am doing here Gaussian naive Bayes. Yes, after that GNB, like yesterday, whatever we done, I'm fitting all the X train and Y train. Just a second. Yes, it's okay. Y train. After that, yes, Gaussian naive Bayes prediction. Prediction is, yes, GNB dot predict. Yes, predict. Inside this I want to see the prediction according to X test value, and I want to see the accuracy. So for that, I need the matrix come from scalar and matrix. Yes, accuracy score, that is Y test. Yes, Y test, and the prediction, that is, yes, like this, the prediction, and I want to I want to print that our accuracy is accuracy. So it will take some time, because for it the classifier is working for, yes, 0.94, that means 94% 81. Okay, am give here, okay, no, yes, I can do it like this, that round accuracy multiply 100 comma 2, yes, like this. Oops. Yes. Yes, now you can see the accuracy is 94.82, but naive Bayes is this is not okay. It's not that is also only 94 points. So we will try it for decision tree classifier. So let's see for decision tree classifier. So my classifier is decision tree classifier. I'm calling the decision tree classifier function. After that, please, I want to feed it. So that means, yes, decision tree classifier dot feed, and I want to feed the data. Yes, copy, yes, paste. After that, I want to need the prediction. Yes, copy. So here I want to give a comment. The comment is, yes, decision. Yes, decision classifier. Yes. Now here I have to change the value, that is, yes, DT classifier prediction, and the prediction is decision classifier prediction, and I want to need its accuracy, and that's why I call the matrix inside the accuracy score like this, and after that, that is y test and the decision tree prediction. Yes, like this. I want to print. Yes, accuracy. Oops. Accuracy is accuracy of decision tree is, yes, like this, and I'm calling the round function a simple function that will print, yes, that will print accuracy multiply 100, and I need 4 float value. Okay, I think it's okay. Now let's check it out. Oops. Yes, that's great. 99.9945. That means decision tree classifier is better than naive Bayes in this, for this data set. Okay. Now I will report classification report if I add this module or not. No. Okay, so don't worry. Just yes, from sklearn, yes, dot matrix. Yes, we will import the classification report, and after that print the classification report of y test. Yes, and for the decision tree prediction. Okay. Yes, decision tree prediction. Now I think it's okay, and you will see, yes, no problem with our precision and recall. All is yes. Oops, it's pretty good. And now you can also plot the confusion matrix. Confusion matrix for what? For these 3 categories. Okay. So I think, yes, everything will clear. Yes, Muskan Kumari. Okay. So today, I think it's 8:30. So after that, I think you can done the confusion matrix, because some with simple code, all of you know. Okay. So I'm stopping here today. So anything else, because tomorrow your violent Python will start, and after puja we will do a image classification. Okay, we will do a project and a malware project that we have like this. We have suppose 3,000 or more images that represent malware. Okay, or some image that represent that it is normal. So after test and train, we'll create a model, and if we give some input in this model, it will give us an output that it is normal or it is a malware. Okay. So I'm stopping here. Please. Anything? I already shared the data set of this DOS attack. So what is exactly for this? Now, exactly this data set, you can see here, this data set is created by some sampling, I think, for the tracing of some packet. So I think you can also test, you can make some test data set for your testing, and you simply, if you give it here the test data set, and after that you can see in this report that where it is a attack and where it is normal. Okay. Yes, thank you. So thank you all. Let's meet again after puja. Okay. So I think you have a pretty idea with what is data science, what is its working purpose. Okay. Jupyter notebook also. Okay, I will share it. But don't want to load in if your computer is a 2 GB RAM or 2 GB RAM. So I think it might be hang. So that's it. So I'm stopping here.